Today let us solve this question. What are the oxidation number of underlined elements in each of the following, and how do you rationalize your results? Rationalize in the sense you have to justify why you are giving just such type of answer, whether it's right or wrong. Okay. So let us go for KI3. Let me increase the thickness here. Yes. Okay. So this is KI3. So let us write KI3. So we know that the oxidation state of potassium is +1. So 1 plus this taken as X, 3 into X, that is equal to 0. So we can write it as 3X is equal to -1. So X is equal to -1 by 3. Right? But we know that oxidation number cannot be fraction. Oxidation number cannot be fraction. So we have to rationalize that one. We have to justify that. So let us write the structure of KI3. So KI3 is actually a coordinate bond will be formed between the iodine. So here this is I2 is iodine molecule. Another iodine molecule has donated its electron to form the coordinate bond. Usually we know that the halogens will have -1 oxidation state. So this iodine has taken -1 here. So that has been spread to these iodines. So it can be the total charge in the compound for iodine can be given as -1. Right? Can be given as -1. Is that clear? So -1 is the right answer for this one. Got it? Next we can go for H2S4O6. Yes. H2S4O6. Let us write this one. So hydrogen we know that is +1. Oxygen is -2. So let us write it as 2 into +1 plus sulfur X we don't know. So 4 into X plus 6 oxygen into -2. Right? So that is equal to 0. So this can be written as 2 into +1. Right? So 2 plus 4x, 6 into -2, -12 is equal to 0. So 4x, that is equal to, minus will be plus here. So 12 plus will be minus here, -2. So 4x is equal to 10. So x is equal to 10 by 4. So this can be written as 5 by 2 or 2.5. Let us draw the structure of this compound H2S4O6, that is S4. So S, 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 and here OH, and here OH, and these two atoms will have the double bond O, this one and this sulfur. Right? So this is the structure of H2S4O6. Let me give you a few examples like HCl. So what happens here? This halogens, chlorine being highly electronegative, to take -1 charge, as usual we know. So this will take over the electron over here. So when the bond is broken, it will be cleaved as H plus and Cl minus. Right? But in the case of Cl2, if the bond is broken here, this chlorine will take its electron, this chlorine will take its electron. So the oxidation state is 0 in the case of Cl2, right, in its pure form. So we'll apply this concept to this molecule. Right here, the sulfur is attached to electronegative oxygen atoms. That is, here this oxygen atom will take the 2 electron from here, and this oxygen atom will take the 2 electron from here, and this oxygen atom will pull 1 electron from here. So this can be written as 2 plus 2 plus 2 and plus 1. So totally 5 electrons, plus 5 electrons has been given by this sulfur. So this sulfur acquires +5 oxidation state. And here these two are same species. There is no difference in electronegativity. So it will be 0 here. And here these two two are same species, so there is no difference in electronegativity. The oxidation state is 0 here. Take this sulfur, the same concept will applicable here. This is highly electronegative, so it will take away the 2 electrons, so plus 2. And this is highly electronegative. This oxygen will take the 2 electrons from here, so again it is plus 2. And here in this side, this oxygen is also highly electronegative, so it will be plus 1. Right? So it can be given as, the oxidation state can be given as plus 5. So for this compound, the oxidation state can be given as plus 5, 0, 0, plus 5. Got it? So this is the oxidation state of H2S4O6. Is that clear? Now let us go for Fe3O4. Let us write it Fe3O4. It means that 3x. That is 3 into x plus oxygen is minus 2 as we know. 4 oxygen are there. The 4 into minus 2, that is equal to 0. So 3x minus 8, that is equal to 0. X is equal to 8 by 3. Got it? X is equal to 8 by 3. Again, what is that? This is in fraction. So oxidation number cannot be fraction. Let us justify this one. We will rationalize this one. So this Fe3O4 is nothing but Fe2O3 and FeO. Right? So here we can write as Fe3O4. Right? So let us find out the oxidation state of ion in these two compounds. Right? In FeO, we know that oxygen is minus 2. So ion should be plus 2 here. In the case of Fe2O3, we can take it as 2 into x plus 3 into minus 2, that is equal to 0. So this can be written as 2x minus 6 is equal to 0. So 2x is equal to 6. So x is equal to 6 by 2, that is equal to 3. So here this is in plus 3 oxidation state. Here this is in plus 2 oxidation state. Got it? So this is the reason for Fe3O4. Next we can go for CH3CH2OH. Right? Let us write here CH3CH2OH. So this can be written as C2H5 plus 1 6. 6O. Right? So here we know that carbon is X here. So 2 into X, 2X plus 6 into plus 1 plus 1 into minus 2. Only one oxygen. So that is equal to 0. So 2X plus 6 minus 2 is equal to 0. So 2X plus 4 is equal to 0. Then X is equal to minus 4 by 2, that is equal to minus 2. That is equal to minus 2 here. So the oxidation state of carbon is minus 2 here. And here next we can go for CH3COOH. Yes, CH3COOH. So this can be written as CH3 C double bond O OH. So we know that in water it will be divided as H2O. That is, it can be dissociated into H plus and OH minus. So the oxidation state of OH is minus. This may be written as minus 1. And the oxidation state of methyl group is plus 1 always. So from this we can find out the oxidation state of this carbon. This oxygen is minus 2. As you know, this is minus 2. So we can write it as this C. Let us write like this: plus 1 plus X plus minus 2 plus minus 1, that is equal to 0. So minus 1 plus 1 get cancelled. So X minus 2 is equal to 0. X is equal to 2. Right? So the oxidation state of carbon is plus 2 here. Got it? That's the end. If you have any doubts, just let me know in comments. Let me clarify. Thank you all.